This video of the Phoenix II will go over the basics of calibrating for zinc on the Phoenix II using direct excitation. All the Phoenix II set up for the zinc analysis will either have a fixed or a movable target with a molybdenum filter. This is the basic setup for all zinc applications. The only difference from one zinc application to another is the microamp settings, the overlap blank used, the blank should match your matrix, and possibly the region of interest settings as these change from detector to detector. If you ordered a Phoenix II for this specific application, the factory would have set up an example calibration for zinc to get you started. You can edit this existing method for your needs or copy it to get it started. For this video, we are going to start by making a new method from scratch. To the right of the Analyze button, select the active method, and at the right, select New. Select Name, and key in the method name that you would like to use and select OK. And select Create. Now select Add Element, select Edit, select Z, select Atomic Number, key in 30, select OK. Now the atomic number, chemical symbol, and common name are all inputted into the table. Select Done. The label is just a name. You can label it zinc or zinc oxide, for example. The units is the unit of measure. You can use ppm or percent. Again, this is just a label. The digits is the number of digits reported to the right of the decimal place. Now select ROI. This is the region of interest settings for zinc. The software will start with the default setting. The low and high regions are typically widened from the default values. Select the large conditions button to the top right. Select Edit. Select kV and edit it to 25. Select OK. Select microamps. Key in 45. Select OK. A typical settling time, this is the warm-up time, is 3 to 6 seconds. The target should be the moly filter, or if you have a fixed target, this will be left blank. The count time is the analysis time. In general, the goal for almost all applications is to have the overall count rate for the highest concentration sample around 20 to 23,000 counts per second. Once you set the voltage, you set up the method using a lower current. You put the highest concentration sample in the aperture, close the sample door, and select Test. The OCR value is displayed to the left. If the counts are too low, raise the microamp value. If the OCR value is too high, lower the microamp value and try again. This step is completed by trial and error. So now I want to check to see if my microamp settings are set correctly. So I have my highest concentration zinc sample on the aperture, the door is closed, and I'll press Test. I can see right away I do not have enough counts. I don't have 20,000 counts, so I'll select Done, and I'll raise the microamps. And again, I'll select the Test button. And now I have way too many counts. This will decrease the life of your detector. So I'll go change the microamp settings. This time I'll lower them. I had too many counts. And now I'll select Test again. Okay, now I can see I have very good count rate. I have 20,000 counts. Now I want to check the zinc region. I can actually select On, and we can see that this peak right here is the zinc peak. If I select to the left side of the peak, I can see here that KEV is like 7.4 to 7.5. If I select the right side, It's about 9.8. Now I need to remember those numbers. So I have 9.8 and 7.5. And now I'll select done. Now my microamp's set correctly, so now I need to go edit my region of interest to match what I just saw. So I'll change the low to 7.45, and I'll change my high KEV to 9.8 and select done and done. And now my element is set and my conditions are set. Now we need to select the background regions. Select conditions again, edit, and select background regions. Here we'll select new, and these will be the Molly K lines. They should be set to 12 and 18. Select OK and select done. Select done and done again. And eventually we'll get back to the element screen. And here we'll select overlaps. Here we want to select the word ignore and select calculate. We'll select the word pick and pick the background region we just created. The question marks will be calculated later by the software once we run the overlap blank. You do not put any values here at all. Select done. Now the method setup is complete. Select done. Save if the save button is green. Now we'll select acquire. Select overlap samples. And now place the blank sample on the aperture. Close the door and press analyze next to the row with the blank. The blank should contain no zinc, and it should best match your matrix, either be in the polyethylene backscatter, the Teflon, DI water, or anything with no zinc. The blank typically has less counts than the highest standard. When the blank analysis is complete, select OK and Done. Now we'll select Assayed Standards. The Assayed Standards list is blank at first. You need to enter your standard information. You can add one sample at a time and then analyze it, or create the entire list. Select New, select Label. Here you can name it a sample name or the concentration. This is just a name. And here we need to put in our percent zinc. And select Done. Now the sample is on the list and is ready to analyze. A sample with less zinc will have less counts than your highest standard. Once all the assayed standards have been analyzed, the fit should be confirmed. Select OK, select Done, select Done, select Save, Complete Save, and OK. Now select Configure. Now select Fit or Auto Fit. The Auto Fit will pick the best fit. However, the Auto Fit does not remove bad samples or select alpha corrections. However, alpha corrections are never calculated for single element applications. Once the fit is selected, you can select Edit, and you can select your slope, offset, or curvature manually. Or if you have one sample that you believe is bad, you can select Data, and you can choose to ignore that sample. See, now my fit's better. I can also look at the correlation chart, and I can see that one sample here has the X showing which sample was not used in the fit. The goal of selecting a fit is to pick a valid setup with the lowest standard estimate of error. A valid fit will have a positive slope, an offset value that is less than the lowest standard concentration, and a curvature with a small absolute value. The SEE is normally about 1% of the highest standard when using a set of well-assayed standards for simple applications. Once the fit is selected, you can set up the standardize feature. The standardize is used to prolong the life of your calibration and will correct for drift. Heavier elements like zinc don't require this feature to maintain stable results. However, the pass-fail when updating standardize shows that the instrument and calibration are still working well and the results should be valid. To set up the initial standardized reference value, we need to select Done, Done, and we need to save, Complete Save, and OK. Now select Adjust. Select Standardize Configuration and select Acquire. We can give the sample an ID and press OK. The sample you use may be one of the single element SES samples supplied with your analyzers or one of your samples. The sample must be stable and or reproducible. The SES supplied with your analyzer are not completely homogeneous, so mark the sample so that you can align it the same way each time for analysis. Then to analyze, we'll put the sample on the aperture, close the door, and press Analyze Original. When the analysis is complete, you'll see now that you have reference counts. Select Done and Done to return, and Done again, to return to the main analysis screen. Now the Standardize button is enabled. When you see a QC sample start to drift, this is the time to update your Standardize. So you'll put the sample on the aperture, close the door, and press Standardize. The analysis will automatically start. When the analysis is complete, you'll have the reference count and the new recent count, and now a factor. Right now it's very close to 1 because we just analyzed it. This factor will be applied to your unknown results now. Select OK to go back to the main analysis screen. Once the calibration is complete, you should analyze a few of the assayed standards to ensure that they read correctly. A sample that read poorly in the calibration and was ignored will still read poorly as an unknown sample. If you are satisfied with the calibration and your results, it is time to back up the database. Put a USB drive into the back of the analyzer. Select System, select Storage, and select Backup. Now select Backup again. And now I'll have a backup zip file. It's backup and it's .your serial number. This is specific for your analyzer, .zip, and there'll also be a .properties file. With these two files, you can restore back to this time and date. If you already have an existing calibration, you have two options. You can actually overwrite the existing data, or you can copy the existing method and then calibrate it. To calibrate over the existing method is simple. Select Calibration, select Adjust, select Standardize Configuration, and Reject. You want to get rid of this factor so it's not applied to your newly assayed sample measurements. Select Done, and now just select Acquire. You go to Overlap Samples, and you analyze your blank. You go to Assayed Standards, and you'll analyze your standards that are already listed. The new analysis will overwrite the old data, or you can add new samples to your list or edit this list. And just like before, you will go and you'll select your fit, and you'll set up the standardize. And then you're ready to go. Another option is to select calibration and configure and then options. And here we can copy the method and say it's 2018 now. So now I can name it, I think, 2018. It'll either bring over all the sample data or just the sample labels. If you select grayed out, it'll only select the sample labels. And select copy. So now I'm in my new method. I can see that my adjust is already cleared out. If I come here, I go to acquire, I'll analyze my blank, I'll analyze my standards, and I'll pick a fit. So you can see that calibration is very easy.